Good morning, sir. Our report is about order of a group and order of an element. Consider a group G having an n element where n is finite in number. Now, we define order of a group. The number of elements available in the given group, since the number of elements in the given group G is n. Therefore, order of this group of the n is if the number of elements in a group is infinite, then its order will be also considered infinite. Again, the less order of a group is 1, since a group at least contains the identity element in order to be a group, therefore the less order will be 1. Order of element. Before coming to order of element of a group, you need to understand something here. If G be a group having n elements and O be its operator, then A to the power of k is equal to operating A with itself k times, i.e. A to the power of k equals to AO k times. So, order of any elements A of the group G is defined as the less positive integer k such that A to the power of k is equals to E, where E identify elements and belonging to G. Order of an element A is denoted as OA. If no such positive integer exists such that A to the power of k is equal to E, then OA will be considered 0 or infinite. Also know that order of the identity element E is 1. Now, if m is any positive integers such that A raised to the power of m equals to E, then order of the element A cannot exceed m. This is because order of an element is the less positive integers, so if we exceed m, then it will contradict this fact.
This is the continuation of our report about order of a group and order of an element. The order of a group in its cardinality, that is the number of elements in its set. While the order of an element in a group is the smallest positive integer for which is the identity element. The order of an element of a group. If G is a group and A is an element of group G, the order or period of A is the least positive integer n such that A raised of n is equals E. So we have two examples here. Let's proceed to example number 1. Example number 1, find the order of its elements of the multiplicative group G, where G is equals the element 1, negative 1, I, and negative I. Since 1 is the identity element, its order is 1. Now, negative 1 raised of 1 is equals negative 1. Negative 1 raised of 2 is equals negative 1 times 1 is equals 1. Hence, the order of negative 1 is equals to 2. Again, I raised of 1 is equals I raised of 2 is equals negative 1, I to the power of 3 is equals negative I to the power of 4 is equals 1. Therefore, the order of I is equals to 4. Similarly, negative I to the power of 1 is equals negative I to the power of 2 is equals negative 1, negative I to the power of 3 is equals negative I to the power of 4 is equals 1. Therefore, the order of negative 1 is 4. Let's proceed to the second example. U of 15 is equals the set of, under this set we have the elements of 1, 2, 4, 7, 8, 11, 13, and 14. Under multiplication, modulo of 15. So let's start with the element 1. 1 to the power of 1 is equals 1, which is the identity is 1. Then second element, 2 to the power of 1 is equals 2. 2 to the power of 2 is equals 4. 2 to the power of 3 is equals 8. 2 to the power of 4 is equals 16. Modulo of 15 is equals 1. So, the order of the element 2 is 4. Then, 4 to the power of 1 is equals 4. 4 to the power of 2 is equals 16. Modulo of 15 is equals 1. So, the order of the element 4 is 2. Then, 7 to the power of 1 is equals 7. 7 to the power of 2 is equals 49. 7 to the power of 3 is equals 343. 7 to the power of 4 is 2401. Modulo of 15 is equals 1, which is the identity is 1. Then, the order of the element 7 is 4. Then, 8 to the power of 1 is 8. 8 to the power of 2 is equals 64. 8 to the power of 3 is 512. 8 to the power of 4 is equals 4096. Modulo of 15 is equals 1. Therefore, the order of the element A is 4. Then, let's proceed to the 11. 11 to the power of 1 is 11. 11 to the power of 2 is equals 121. Modulo of 15 is equals 1. Therefore, the order of the element 11 is 2. Then, 13 to the power of 1 is 13. 13 to the power of 2 is 169. 13 to the power of 3 is 2197. 13 to the power of 4 is 28,561. Modulo of 15 is equals 1. Therefore, the order of the element 13 is 4. Then, the last one is the 14. 14 to the power of 1 is 14. 14 to the power of 2 is 196. Modulo of 15 is equals 1. Thank you.
This is our assessment. Please read carefully and choose the right answer.